This is Tally Teaches again, here talking about inequalities, but this time we're talking about absolute value inequalities. The most important part of absolute value inequalities is the fact that we need to remember there's going to be some fun here. Alright, so we're going to have to remember some things. So the main thing you're going to have to remember, there's two facts that you're going to have to remember. If you're getting the absolute value of x is less than a number, I'm just going to write number, then you're going to have to think about the fact that this is going to create an AND statement. And that means that you're going to have to write a three-part statement where x is between them, and you do the negative version of the number and the positive version of the number, and then you do any solving you need to do and graph the problem. When you have a greater than statement, if I see an absolute value of x and I see it's greater than a number, then it's going to end up being an OR statement. It's going to be x is less than the negative number, or x is greater than the positive number. And then you solve what you need to solve, and that is going to be the way it goes. So we're going to do an example or two. So we've got here absolute value of x is less than 3. So we see from the pattern up above that it's a less than answer, it's a less than problem, so that means it's going to be an AND statement, which means I can just put whatever expression is right here in the middle between two less than symbols, and I'm going to put the positive version of the number to the right and the negative version to the left. This one does not need any more solving, so it's pretty much done. Both of those less thans are going to be open circles, so I'm going to put an open circle on -3, an open circle on +3, and fill in the gap between the two. And you're done. Alright, next up we see absolute value of x is greater than or equal to 2. So we're going to end up being working on an OR statement. The OR statements for greater than, so greater than creates an OR statement, so that means I'm going to say that x is less than the negative version of the number, or x is greater than the positive version. Notice that I used the same type of symbol since this said or equal to. Everything else has to say or equal to as well. This is pretty much solved now. There's no additional algebra to be done, so I'm just going to graph these two statements, less than or equal to -2. I'm going to put a circle at -2, fill it in, and go to the left. Or I'm going to do the greater than or equal to 2. So I'm going to put a filled in circle here and go to the right. And that is the solution to that one. This is negative absolute value of x is less than or equal to 27. Before I do anything, before I even look at whether this is a less than or equal to or a greater than or equal to, I'm going to have to isolate to the absolute value x because it's not really by itself. Because this negative means that I'm taking -1 and multiplying it times the absolute value of x. So what do? I am going to isolate it by doing division by -1. That's going to make these disappear. And then I'm going to have the absolute value of x on the left side. On the right side I have a -27, but keep in mind, if I use a negative number to divide, then that means this symbol right here is going to flip. So this less than is actually going to turn into a greater than. Since it's greater, what I notice here is the absolute value of x is greater than or equal to negative 27. Well, guess what? This is one of our special situations. Since absolute value is always positive, and I'm comparing it to a negative number, it's greater than or equal to negative 27. Aren't all positive numbers greater than negative 27? All right, so that means this one is going to be all real numbers. So let's change one of these problems, and that means the graph is going to be different. Let's say that I've got 1/2, the absolute value of x is, well, first I'm going to add a number like +1 or something, is less than or equal to 14. So first I get rid of the 1/2 by doing the inverse of multiplying by 1/2, and that would be multiplying by 2. That gets rid of the 1/2, leaving me with absolute value x plus 1, and that makes 28. So now it's a less than, so that's an and statement, so that means it would be the entire expression is going to be between the negative version of 28 and the positive version of 28. Then I'm going to subtract 1 from all three parts. Get 29 is less than or equal to x, which is less than or equal to 27. So pretty much you're just going to be coloring everything between negative 29 and positive 27. Alright, that's it for Tally Teaches, and we'll see you next time.